So let me go ahead and start with what exactly does it mean by point estimate. So a point estimate, I'm just going to put a PE. A point estimate is you're going to give me exactly one value. In the example that we took, the point estimate was 21.1. Usually it is not preferred to give me a point estimate. In statistics, you always look for interval estimate. That means you will tell me from what point to what point do you think that the population mean is going to be. So instead of saying 21.1, I can say I think the population mean is somewhere from 18 to 25. So I'm going to say, you know what? Instead of saying my population mean is 21.1, I will give you a range of values. I'm going to say, hey guys, you know what? The population mean can be anywhere from 18 to 25. So you are giving me a lower limit and an upper limit. So the population mean can be anywhere from 18 to 25. So it could be 18, 19, 20, 21, 22, 23, 24, 25, or 18.1, 18.2, 18.3. So just by giving an interval estimate, you gave yourself a big room to make errors and to be more confident. Okay, so now I want to show you what exactly does it mean by confidence interval. Remember, I will not be asking you to show any of this in your test, but it's always nice to know what it means. So I'm going to go ahead and pick confidence interval here. Remember, majority of our distributions are normal distributions. I'm going to say, I'm going to keep a mean 50. The population mean is 50 and the population standard deviation is 10. Be very careful with the notations here. And I want to say I am 95% confident and I am going to take a sample size of 35. You don't need to know any of that, and I'm going to go ahead and compute. So what do you think just happened? Let me explain what's happening here. I took 100 intervals. So each interval has a sample size. So let me go ahead and click one of them. So each interval, oops, close. Okay. Each interval has a sample size of 35. Do you see that? So I took sample sizes of 35. So how many samples did I take? I took 100 samples. I took 100 samples. Remember what I told you? I said my mean is 50, the population mean is 50, and standard deviation is 10. And I am 95% confident. So what exactly does this mean? Every sample that I take, I will have a lower limit and upper limit. Do you see that? That's the margin. So lower limit and upper limit. So what I'm telling you here is, I'm telling you that if a large number of samples are collected and confidence interval of each sample is created, that is, I create a lower limit and upper limit. You can click on any green or any red, you will see a lower limit and upper limit. So I'm taking a sample, I'm creating a lower limit and upper limit. I'm taking another sample, creating a lower limit and upper limit. How many samples am I taking? 100. So once I take this 100 samples, what am I telling you? I'm telling you that 95% of these samples will contain population mean of 50. If you look at this, all the green ones contain population mean. See, so somewhere or the other, they contain the population mean. The red ones do not contain the population mean. So you see here that 95% of the samples are green and the majority and the 5% are not. So when I say confidence interval, I'm saying that 95% of my samples will contain the population mean. So if I'm 99% confident, let's go ahead and see for 99% confident. You see that when I'm 99% confident, I don't have any reds. So I'm telling you, hey guys, I'm taking the samples, I'm taking a sample size of 35 and I'm taking 100 samples and I'm 99% of my samples contain population mean. Now let me show you what happens if I take 50. You will see a lot of red spots. Do you see that? So what am I telling you? I'm telling you only 50% of my samples contain population mean. Now, as I keep increasing the confidence interval, the green values keep increasing. You see that? 70. Let's look at 80. Let's look at 90. You will see that the red kind of disappears. So the reds are the samples that do not have my sample mean. You see that the lower limit is 50 to 55. So they do not have the sample mean here. My sample mean is 50. So if I take a number line, 50 is here, right? And I have 51, 52, 53, 54, 55, 56. So if I take a red dot right here, so they're telling me that their mean is somewhere here that does not include my population mean. So all the red samples that you see are the ones that do not have my population mean. So as I keep increasing my confidence level, you see that the red spots kind of disappear. So 91, I have some red ones. 92, I still have red. 93, I still have red. Let me go to 75. You will see a whole lot of red. You're only 75% confident. So you're telling me only 75% of my samples contain the population mean. So now this kind of marries into critical values. Let's look at what critical values are. I am trying to explain what critical values are. So let me go ahead and expand this one. Remember this normal calculator? This is the area under the curve. So see how everything kind of marries into one another. So this is the area under the curve. The maximum area is 1. So the maximum confidence level that I can have is 100%. So what I want to show y'all is to find critical values, what do we need to do? But first of all, let's see what critical values are. Remember, I'm always trying to give you an interval estimate. So if I'm 60% confident, this is a standard normal curve. So if I'm 60% confident, what are my values? My range is negative 0.84 to positive 0.84. Do you see that? If I am 70% confident, that means the area under the curve has to be 70. If I'm 80% confident, the area under the curve has to be 80. If I'm 90% confident, area under the curve has to be 90. So if I'm 95% confident, area under the curve has to be 95. So the critical values are your z-scores that will separate your sample statistics from the rest of the area. So here, if I ask you what are the critical values for 99% confident, so what do? Let me show you the process. You go to stats, calculators, normal, right? Critical values are always two values, one positive, one negative. Remember, you always give me an interval estimate, which is going to be the lower limit and upper limit. So critical values are two values. So if I ask you critical values for 95% confident, you will, let me go ahead and change this, 0.95. So what are your critical values? Your critical values are negative 1.96 and positive 1.96. So you're telling me that the z-score at negative 1.96 to positive 1.96, the whole area is 95%, 0.95%. Okay? Now if I ask you for critical values for 99%, you simply plug in 99 and compute.